when we're thinking about forces between objects, the first thing that we probably want to do is to check that we know what we mean by a force. So forces change the shape, motion, or state of rest of an object. Okay, so let's think about what this actually means. So when we're talking about forces changing the shape of an object, we're talking about it being stretched or squashed. Okay, so if we've got a spring and we apply force to the spring, then we're going to stretch the spring. If we've got a stress ball and I apply force on it, then I'm going to squash it. Okay, when we're talking about motion, we're talking about, are we speeding up, slowing down, or changing direction? Okay, and then state of rest. And what we mean by state of rest is whether it is stationary or not. Okay, so I guess it's important as well at this point to add that forces are measured in newtons. So that's the unit for force. The symbol that we use for force is F. The symbol that we use for newtons is a capital N. That's useful for when we start to do equations using force. So some forces, we need to know names of different forces. So some forces need to touch. And these are called contact forces. And examples of contact forces are things like friction and air resistance, which we could call drag together. Tension, so when you apply a force to stretch something, and then something that you might not have heard of before, but you will have encountered, a normal contact force. Okay, and this comes up, sometimes you're asked to label forces. So like these pens are resting on the table, so there's a force of the pen on the table and then a force of the table on the pen, and that's a normal contact force between those two objects. And then we have non-contact forces, and I'm sure you can guess what these are, and this is where they don't need to touch. So examples of non-contact forces are things like the force of gravity, magnetism. So in year 8 you lived on about magnets, putting stuff in a magnetic field, making iron filings move and that sort of thing. And then electrostatic forces, which are between charged particles. So we've learnt before about protons being positively charged, electrons being negatively charged. So the forces to do with charged particles are electrostatic forces. Okay, so if we think about what we know about forces already, think of an example of a force. If I hit the table like this, my hand is exerting a force on the table. But I also feel it. I can feel it in my hand that force has been exerted. And that's because not only is my hand exerting a force on the table, but the table is also exerting a force on my hand. And this is what's called Newton's third law. And this is that when two objects interact, they exert equal and opposite forces on each other. So the example that I used was my hand hits the table. So my hand exerts a force on the table. We could say that that's a force going down, and so therefore the table exerts a force coming up, because then it is equal and it is opposite. Let's just think of an example that you could be given. You could be given an example where you have a nail that is being hit into kind of a piece of wood, and that you've got a hammer. Terrible drawing, but oh well. If the hammer exerts a force onto the nail, which is 50 newtons, then there's also going to be an equal and opposite force of the nail on the hammer, so it'll be 50 newtons but upwards. The other thing that you can think of is if you have, because this is the one that people find tricky, so you have a person and the earth, okay? We know that there is a force pulling us towards the centre of the earth because that's due to gravity. We would call that the weight of this person, okay? So weight would be the force of the earth on the person. And most of us know this already. We encountered this in year 7. We've been talking about using the difference between weight and mass in P1 as well. So the force of the earth on the person. But from Newton's third law as well, we also know that there will be the force of the person on the earth, because the two objects, the person and the earth, are going to be interacting, so there will be equal forces but in the opposite direction. Have a go at the questions you've been set. So you could either pause the video now and have a go at them and then come back, or you could listen to the question being read, pause the video, have a go at it, and then listen to the explanation straight away. So with a question like this, you get given information at the beginning and then questions that are relating to the information. The temptation for a lot of people is to just jump straight away to the bit that you have to do something with, but then you'll be missing information from here. So it's a good exam technique for you to read all this information first before you approach the questions. So high diving is the act of diving into water from extreme heights. In 2013, at the World Aquatic Championship, a new competition was introduced, a high dive from 27 metres. The highest dive board in the Olympics is 10 metres. From this height, dives can take up to 3 seconds, with divers reaching speeds of 90 kilometres per hour before entering the water. In this diving competition, divers enter the water feet first because of the high risk of head injury. The water stops the divers in less than a second, and they rarely go deeper than 4 metres. So this gives us the context of the question. So name one contact force and one non-contact force acting on the diver as they are falling through the air. So a contact force would be the force of the air on the diver. And we can think of this as basically being air resistance. A non-contact force would be the force of the earth on the diver, which is basically their weight or the force of gravity. So for the contact and non-contact forces you named in question 1, identify their equal and opposite force. So we can look at how we've written this force. So for the contact force, here we've said it's the force of the air on the diver. The equal and opposite force is going to be the force of the diver on the air. So it's the same force, but it's the opposite way around. So let's do the same for the non-contact. Here we've written it as the force of the earth on the diver. So the opposite way around would be the force of the diver on the earth. And we can practice this skill again on the next question. Name one contact force and one non-contact force acting on the diver as they enter the water. So the last question was when they're falling through the air. This question is the same idea, but as they're entering the water. So once they've entered the water, the contact force, we can't say it's air resistance anymore, but we could say that it's the force of the water on the diver, which we could call water resistance, we could call it drag. And for the non-contact, well, they're still falling, so we would still say it's the force of the earth on the diver. And then again, for the contact and non-contact forces you named in question 3, identify their equal and opposite force. So very similar to how we've done it before. Instead of the force of the water on the diver, we will now have the force of the diver on the water. And for the non-contact, it would be the force of the diver on the earth. Explain why, in terms of forces, there is a risk of head injury when diving from this height. Suggest why the divers would choose to enter the water feet first. Well, there's a risk of head injury because the divers push on the water with a large force. And remembering what we talked about earlier, for every force there is an equal and opposite force. So if they're pushing on the water with a lot of force, the water is going to push on them with the same amount of force. So the water pushes back with an equal and opposite force. So if they went in head first, then their head would be taking that huge force to start off with. If they enter the water feet first, then by the time their head gets into the water, they'll have slowed down. And that's if they go in feet first. Because they'll start slowing down as soon as their feet hit the water. So by the time the length of their body has gone through, they'll have slowed down a lot by the time it gets to their head. Okay, the text describes the diver as falling through the air for 3 seconds and then being stopped in the water in less than a second. Describe the motion of the diver as they enter the water and explain it in terms of forces acting on them. So when they hit the water, when they enter the water, the diver will decelerate, so they slow down. And this is because the drag in water is greater than air. So they're going to slow down much more than they did in the air. So it's an upwards force on the diver, so it's opposite to their weights, like the force that's pulling them down, and so it will have an upwards resultant force